Okay, recording. Hello, Care. Hopefully, Kevin, Little, Minatalla, Ramsey, Harp, Abby, Mobla. Hello, everyone. Probably today everyone busy with their portfolio projects or minor projects, but it's okay. We keep going, and they can watch a recording after. So today we gonna do permutation. It's kind of the same as we did yesterday. It's just this one. So the problem here is like they're gonna give us 1, 2, 3, for example, and we need to find out all the possible permutation. So again, array nums with distinct integer return all possible permutation. You can return the answer in any order. I hear my mic doing some noise. Not sure why. Okay, it's okay. So 0, 1, it can be like 0, 1, 1, 0, 1 is 1. And for 1, 2, 3, it's gonna be 1, 2, 3, 1, 3, 2, 2, 1, 3. So we kind of like gonna keep flipping them until we find all the possible solution. So this is a problem. Who have any like question about this or like something not clear? Please go ahead, because this is gonna be fun. I hope so. What you guys think the efficient solution for this? Any thought? Any thoughts? So one of the solution could be like we did with the other one, is like backtracking, right? So we can like imagine like recursion, yeah. So we can like set up one. So our array is 1, 2, and 3. Let me see why my PC is lagging. So we say one of possible solution, or like most efficient solution, is like backtracking. So if they give us 1, 2, 3 and they say generate an array that have all possible permutation of this, so like 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So like we're gonna have to loop through each element in the array and generate a new permutation. So if we think of it like a backtracking, it's kinda hard to imagine, but let's think of it like we're gonna launch our recursion on all these elements. So think of it, that's gonna be loop that's gonna loop on all each element. So gonna loop on elements, gonna do something here, right? And when we're gonna finish this something, we're gonna have an array that have all possible permutations starting from 1. For example, if you notice here, notice this starts from 1, 1, and then this starts from 2, 2, then starts from 3, 3, right? So it like splitting something here, right? So like if I did deal with 1, then I got all this all the rest of the array, like I flip them, right? And then I go to the next one, I got 2, and then I flipped all the rest of the array, because there is because there is just two elements at the right side, so I'm gonna just have two possible permutation, right? 1 3 or 3 1, and then I'm gonna go to 3 and I'm gonna flip all the possible like numbers. So when we're gonna deal with this, we finish, we're gonna go to the second number, we're gonna deal with it, we're gonna finish. So we're gonna add more to this results, right? So the first one gonna add 2, this one gonna add another 2, we're gonna go here, we're gonna deal with it, and when we're gonna finish, gonna find another 2. Now what is inside this circle? What is going on here? So that is like the backtracking. Let's try to see how to like split it to parts and see, just like pseudocode, or like imagine how it will work. So for example, we are in 1. Now in 1, it's like we're gonna have we're gonna launch device from here on number 1. Now this device we're gonna launch, we're gonna have the array of the rest, right? These 2 right here. So the rest of the array, or like if it had, so let's say we are in the middle. For example, we are in the middle, so the rest of the array is 1 and 3. So any elements in the right or the left. Maybe we can even optimize it, but I'm not sure about that. But yeah, let's go with this and see if we can optimize something there. So we have 1. Now we're gonna launch device on 1. The device we're gonna launch gonna have like this 2 3. So like this is our new array, or like think of it combination, and we're gonna have the combination, right? Because we are looking for this combination. Now we are in the first one, so our combination gonna have one area there, right? And then we need to flip this so we can add them too, right? Like if you keep focus on this one, we have 1 1 1. Okay, here's the combination gonna have 1. Okay, nice. Now the rest I need to flip them. I'm gonna send this setup to the backtracking, so I'm gonna have another DFS that I'm gonna give it so this DFS I give it new array 2 3 and 1, and then I'm gonna give it first I'm gonna loop on this, right? So when I'm in this DFS, I'm gonna loop on this array, right? So the first loop I'm gonna add it here, and the second loop I'm gonna add it also here. So like it's gonna be so let's loop on 2. So when we're gonna go to 2, it's gonna be only 3 left in the let's say it's our array, and this, do we call this currents? Okay, let's call it current combination. So this is gonna be 1 2, right? 1 2. So it's like we remove it from here, we put it here. So 1 2, and then this also we're gonna launch another DFS on it, and it's gonna become empty, right? And the current's gonna be 1 2 3. So we launch on 1, we get the rest, it's gonna become our new array, and then now we have 2 numbers, so we're gonna have two loop. So this is gonna be a loop, right? A loop that loop through the elements. So the first one, when we're dealing with 2, we're gonna generate we're gonna launch DFS on 2. It's gonna remove that number 2, so we're gonna have we're gonna add that number to the combination. So we are building the first one 1 2, and then we're gonna end up with 3 in the array left. We're gonna add it, we're gonna launch defs on it, where we're gonna add it to combination, and the array gonna be empty. Now we have, and when we look out to our current, if we find it, if we find our array empty, we know that the current is one of the permutation. Now this gonna backtrack to this, and this gonna backtrack to this, and then this one gonna loop to the second number, right? Because this one also, if it had 2 numbers, it's gonna loop to second number, but there's only 1. So when it's gonna loop to number 3, we have 1 combination, so it's gonna remove 3, it's gonna put it in the current combination. So only 2 gonna left, so we're gonna send 2 in the new array, and the current combination is gonna be 1, 3, right? But we didn't finish because we still have something in array, right? So we're gonna launch another defs. This time we're gonna remove 2, we're gonna add it to the combination. So any number we remove from the array, we're gonna add it to the combination until we find out empty array. Now we have empty array, right? We're gonna launch on this defs, like on this array. It's gonna be 1, 3, 2, and because this is empty, so this is like our base. When the array is empty, we gonna just add this to result, which is 1, 3, 2 here. And now this gonna backtrack to this, and this gonna backtrack to this, and this gonna be finished. Now this gonna move to second number. Again, it's gonna launch. Let's do it here. It's gonna launch. So imagine of it's our array. It's remove itself, and it's gonna put itself in this current combination, right? 2, and the array we are treating is 1, 3, right? We remove it. Now this array is not empty, so again we have 2 numbers, so we're gonna start looping from the first one. So it's gonna remove itself, so only 3 gonna be in the next round, and 2, 1, and again it's gonna remove itself, and we're gonna add it to combination, so it's gonna be empty array, and then 2, 1, 3, 2, 1, 3, 2, 1, 3, another combination. So far we have 3 combinations, this one, and this gonna backtrack to this, and this one is gonna finish, and the loop gonna go to the next element. So as it is looping here, it's gonna loop here too. I'm not sure, I see someone opening camera. Yeah, so 2, 1, 3. Now we loop to 3, so 3 also gonna do the same thing. We have 3 and 2, so we're gonna remove 3, we're gonna add it to the current combination. So we're gonna end up with 1 and 2, 3. So it's like we are like adding from the current array to the current combination until it's empty, and then we return. Then we're gonna remove 1. It's gonna become empty, and we can add it to the current combination through 1, 2, 3, 1, which is we found this one. Now when we find this empty, we add this to the result, and then we backtrack until this finish, this backtrack, we go to the next element, 3. Let's try to build it somewhere here. Now we have 3. We're gonna put it in the current combination, and the array that's left when we remove 3 is 1, 2, right? And now that this array is still not empty, so I'm gonna start looping on all elements, right? Because I want to generate all combinations. So first I'm gonna focus on 1. I'm gonna remove it. It's gonna be only left 2, and because I remove it, I'm added to the current 3, 1. Okay, I'm building my combination. Then the second DFS, I'm gonna remove 2. It's gonna be empty, and it's gonna be added to 3, 1, 2. Now that is one of our permutation we're looking for. 3, 1, 2. So far this, and this gonna backtrack to this, and it's gonna loop to second number. We're gonna do the same. We're gonna launch a DFS, which gonna send it. We're gonna give it like array that it left from this. So we're gonna remove this, and we're gonna remove these elements added to the current. So the current was 3, right? So we add 2. That means 1, 2 is only 1 now. And because this still we have elements here, we're gonna add them. So it's gonna become empty, and the current's gonna be 3, 2, 1. 3, 2, 1. This gonna backtrack, and this gonna backtrack to 3. And because the array is finished, now we have all the combination we did. It's kinda hard to imagine, right? But it needs a bit of time, especially how you can come with a backtrack solution. So if we notice, basically we just have a track of combinations, and we just keep going and like looping on all combination possible. So when we're dealing with one, yeah, we probably should visualize in the Python tutorial. So when we're dealing with the one, we said, okay, we have one. Okay, so for example here, we notice that combination that starts with 1, so we are building this part, right? This starts with 2, so this gonna build in the second, and this gonna build in third. Now we said like, okay, let me put 1 in the combination, and then let me figure out this one, right? So we were like, oh wait, we have 2 number, and then was like, okay, let me figure out all the possible combination with 2, then let me go deal with 3. And because 2 is only one number, so what we did is like we added here, then we left with 3, we added here, and we're gonna go to the second number, we're gonna add it also right here, 1, 3. So when we're dealing with the number 2, it will become 1, 2, 1, 2, 3. When we're dealing with the second number 3, it's become 1, 3, 1, 3, 2. I hope it's clear. Please, if you have a question, let me know before we like try to do pseudocode and then try to code it from pseudocode. Okay, if there's no question, we can try do a pseudocode of this. Let's start from base. This is our base, right? So our base is empty. It is empty. when it gets empty, we like add it to the result. So if array, okay, so we need some place where we're gonna save this, right? Where we're gonna save this element from the array. We can even use the array itself, right? So we can, for example, here we can pass nums and just remove this element and pass what left, which is 2, 3, and then here I'm gonna remove 2, add it here, and then just pass 3. So we can do that, like keep the same array and just remove it, and when we are backtracking we're gonna add it again, right? So when I was, because this is not happening all in same time, everyone is waiting for its turn. So when I'm dealing with this part, other parts are waiting, they are not launching until I backtrack here, then this part starts, and then until I backtrack here, then this part is. So if we modify the same array, it will not impact others, right? So we can like remove 1, add it here, and then send defs with same nums that we remove 1, and then remove 2, add it in the current combination, then send 3, and then when it is empty, then we're gonna when like def is finished, we're gonna start returning this element from that we remove back to the nums. I think it will be more efficient, or we can even like just create another array and wherever, right? What do you think? Do we create another array or like use that one? Another one? Create another array? Okay, let's do that. So let's call it temp array. So we have a temp array. So at first, okay, let's create a backtrack function. So we have def backtrack, right? We know that we're gonna give it current combination. Let's call it current comp, which is this part right here that keep adding the comp and passing them, and we need to pass them this array here that have the new value. So let's call it maybe temp, or let's give it a rest of array, or like array. Let's call it array. So array. So the array is this, and current combination is this. Okay. So we're gonna loop on the numbers, but let's start from this. We said if this array, if array is empty, so length, or like, okay, let's just, if array is empty, what you're gonna do, append combination, so core comp to, okay, we need the results, right? Results array, because results array, it's gonna have all the combination. So we are going on edge backtracking, we're adding combination. So append core comp to result, and so this is our base case. We keep going until the array is empty. And what if it's not empty? If it's not empty, we're gonna do okay, if we append this, we should return. So like return here, right? It's stop. Do we return any value to this? No, right? We don't care really about returning a value because the value we did added to the result. So if not, if it didn't enter here, it means we still have some number. We still have some number inside. If you remember with me, when we had number here, like for example this one, 132, we loop on all the elements inside this array. So loop on all element, loop on all array element. Okay, here I am, I'm looping. Okay, for example, I'm on 3 right now. What I'm gonna do, so what we did is we removed 3 itself and we added to the current combination. So remove current element, current element from, wait, did we remove it? I think we did. So we did remove it, so become 1, but we have an array now. Do we, yeah, so we had this passed to us from array. So remove current element from array. Okay, here is it. We did remove it. Okay, here is it. What I'm gonna do after that, add it to the add it to current combination. Okay, sure, here is it. We add it, right, which is right here. What now? We launch another deface. So the deface, or like backtrack, we're gonna give it array, or like array, and we're gonna give it current comp, right? And this array right here, before it had like it have like 1 3, and the current comp was like 2. Now when we remove it, it's become 1, and the current comp it's become 2 3. And then this we send it to backtrack, another function of a backtrack. And this backtrack, it's gonna do the same. It's gonna say, oh, I still have some number here, so I'm not gonna enter here this. Okay, what I'm gonna do, I'm gonna again remove this, add it to here, and send the backtrack, and that another backtrack gonna say, oh, the array is empty, so let me push this to result. I think it will be more clear in a second when I finish writing this. So we launch backtrack, right? Now notice when this backtrack finish, we need to return this number to here, because we remove it and we add it to the current comp. So we're gonna remove this from here, and we're gonna add it to the array, like we're gonna reverse what we did here. So it like remove back element from what? From current comp, add it back to array. For example, if you notice here, we know it was array was 1 and current comp 2 3, but when this gonna backtrack to here, it should have the same combination and array. Why? Because I will need them when I'm gonna loop to second number. So for example, when I'm dealing, let me choose another car. When I'm dealing with 2, I follow this path. here in this part I'm removing elements from camp, adding it to removing it from num, adding it to camp. But when I finish this and I find out that I found out my what I'm looking for, when I come back to here, I'm gonna move the for loop gonna move to second element. When it's gonna do that, it should have the same element, which is this one, and same element, which is this one, right? But the last one that I have is 1 2 3, not 1. So it's like I need to give back this 3 here. So here I am, I have this, then go back this to here, then here I am, then I have 2 3 1, then I can continue. So now that's why we need to add back it. So we remove current elements from array, we add it to combination. Now we're gonna add it back to the array and remove it from current camp. That's it. I think this is the loop. This is the loop that's gonna keep going back. Okay, so this is the loop. Let's keep going like this, going, then going back. Okay, who is have any question about this pseudocode so far? Please don't be shy to ask. I can repeat it, I can explain from the beginning. There's no problem. Just be you know, be honest here. If you didn't understand, you can say. Even if someone, like for example Minatala said all clear, don't say, oh, if I ask I'm gonna slow them. No, you're not slowing us. I can explain to you, there's no problem. So don't be shy. So backtrack. Also, if you can't talk or something, you can just write question in chat. Okay, so backtrack. Now we need to launch at the start the backtrack. Now how are we gonna do that? So array, we're gonna give it array nums, right? So backtrack, we're gonna give it nums, which is the one that we're processing, and then current combination at the beginning is gonna be array empty, and if the all backtrack finished, that means we have something in the result, so we're gonna return the result. I guess we don't need this one, right? I guess, yeah, I guess we don't need it because it's gonna be nums that it's our array 1 2 3. Okay. If the pseudocode clear, we can try code this one and see how it's gonna work. So to code it, okay. So we have result equal, then we define backtrack, we give it array, it just as a name for argument, current camp. We say if array is empty. Okay, if array is empty, what we're gonna do, let's call it nums so we can feel that we are working. Maybe not nums, maybe just num, because I think if they have the same name that creates problem. I'm not sure, but no, I don't think so, because this is argument, right? Yeah, I don't think they're gonna create a problem. Maybe, I'm not sure. Okay. You know what? Let's ask ChatGPT about this. Gonna be good to learn. If I have both argument call nums. Is that will work fine, or it's gonna cause problem? Python, if you have two arguments with same name, such as num, in your case, it will not cause any issues. However, generally not good practice because it can lead to confusion. You're right. So let's call it nums, or like numx. Let's call it numx. Who care? Now, if array is empty, so if numx is empty, now how to know if it's empty? We can check the length, right? If the length of it equals 0, right? Or we can just simply do if not nums. If not nums, it will also work. Now we said if it's empty, append current count to result. So current count, we're gonna append it to result. So result, let's add it is, and then we're gonna do append. But we're gonna append current count. Now current count, before append this, we are appending reference. So we will have to do like something like copy to like append a detach array. So when we're gonna change it in the future's current combination, the one that we added to results, it will not change. Or there's like this also creates a new copy of combination. Now we added to results and we said return. Okay, let's return here. Don't need else, we can just return. If it didn't enter here, we can loop on all array element, which is numx. So for element in numx. Not sure if we need this or for I in range, so we can use index. Now, do we need index here? Remove current element from array. Can we remove it just by the value? I think we can use that's remove, but maybe if there is duplicates it will remove. I'm not sure. Maybe if we use index it will be better for I in range. Length of numx, and then we can remove this element. So numx, and then remove, and then numx index e, index e. So it's gonna go to that element, remove it. Okay, add it to the cramp. So we probably need to save it, right? Because if I remove it, I can't access it anymore. So maybe save it. Current, right? Current, we're gonna remove the current element, and then we're gonna add it to the current combination. Current, let's say current element. So we remove current element, we append it to current combination, right? Remove current element, add it to current combination, then backtrack. Now we're gonna call backtrack, same function, but this time the numx and the current count gonna be different. The value that's gonna be launched with, it's gonna have this current element remove, and the current combination gonna be new, right? If you remember with me right here, when we were here, for example, when we launch def is, for example, on tree, what we did is we removed the element tree, right? So if we follow this path, notice the new nums, or like nums, have only 2 because we remove it. But notice the current camp, it have 1 tree because we added there, right? And this, you're gonna notice this keep repeating every time here, right? Even this one, if you notice when we're on 1, we remove it, so it's become just 2 tree right here. And when we notice the current camp, it's 1. And here the current camp is empty, right? To have anything. Now we launch the backtrack. Okay, and then after the backtrack finish, let's say this come back, right? It finished its journey. When it finished, what that mean? That mean, for example, it reached this end right here, right? Because each backtrack gonna reach a base case, which is this one. When it's gonna reach it, and when it reaches, what that mean? It mean like, hey, I did find all combination. How did you know that you found all combination? Because there is no more element to add. That the case here. So if you did find more elements, because this is a recursion way, it's automatically gonna return, right? Because this is waiting for it. And then we're gonna need to reset our current camp and an array of nums. So we're gonna reverse what we did here. Here we did remove it and append it. Now we're gonna remove it from here and append it to here. Wait, we need to actually we need to give it same index. We need to add it in same index of E, right? Because if you append it in at the end, then we're gonna have like imagine 1 3 2, but when it's gonna come back, this gonna be like 3 here, or like so through we're gonna, okay, this is current combination, so we're gonna remove this, add it here. So because this array is empty, it's not gonna be effect. But when I'm gonna be here and try to backtrack to the level before, when I'm gonna remove this and I'm gonna push it here, it's gonna end the level 3. So it didn't do any effect. Maybe I'm just overthinking. Okay, is this gonna create any problem? Okay, maybe here it's gonna create a problem. So when I'm here, 2 3 1. Now if I will remove this here, put this code, then okay, here it's gonna create a problem, right? Because notice I have 1 2 3. If I remove this from here and add this, push it here, it's gonna be 2 3 1. Then when I'm come back here, I have different array. Not gonna work. I need to keep order so I can keep going with flow. So here I need always to, when I remove elements from current combination, when I'm gonna add it to the nums, I need to add it the same index it was. So it was 0, I need to add it 0. So here I have I, right? So I have which index I added before. So first let's remove it from current camp. We can just do the pop. Do we? No, pop it's gonna remove it. We can do, but it is in the end. Is pop gonna work? Because we think pop will work. For example, if we did here.
Then bob and enter the index you want to bob. So bob 0 will bob the first element, bob 1 will bob the second element.
Okay, that's a good idea. Pop current camp. Wait, what's the difference between remove and pop? Chart. What's the difference between remove and pop? Yeah, remove are two methods used in my list. So this method is used to remove the first occurrence of a specific value. Huh. Okay. And pop. Okay. Who is better for performance if I have index? If you already have the index item you want to remove using pop in general, more efficient term of performance. Okay, so let's not remove this by the elements. Maybe we do pop here and then we give it I. Right? So numx, just pop this one. Here we can just append that element. We save some line. I hope I didn't go fast here. Just basically before we pop remove, and using pop is more efficient because we have the index. Now we can also do pop here.
You can just numx.pop I, make it equal variable, and add this variable to append. Like you have the value of the element you want to pop, or it's the next element. I'm not getting it because once you pop it, it's not there. So like you can add,
yeah, you're right.
so current
like this?
element,
Like
yeah.
this?
Yeah.
Oh,
I
smart.
think in here you will append just current, yeah.
Okay, so when you pop it, it's return the value. So yeah, this makes sense. Now current comp, I think it's gonna be always at the last element, I believe. So we can just pop right like this because we are popping the last element. So okay, I'm not sure about this. We can see if it did not work.
You want to pop it and then add it to the num. I think yeah, it's the last element you're talking about.
Yeah, we can use this, right? Because it's same element. But we want to add it in same index it was. So wait, did I get you, Minatalna?
What?
Did I misunderstand what you said? So we can pop any elements at the last, right?
Yeah, pop without any argument, just add pop the last element.
Now we need to use, for example, insert short. How to use insert? So insert, you can give it the index and you can give it the value you want to push. So for example, in index 2, 0, 1, 2, I want to push 10. So
I'm not sure you need to use insert because like you removed the element already, so you have the next index. You just need append. I'm not sure, but I think you will need only append.
In this case, yes. In this case, yes. But in this one, no.
In what?
Because we have 2, 3, and we have 1, right?
Yes.
And we are looking to have 1, 2, 3. This is the result of what we want. So if I remove this, I pop it, and the append is gonna become 2, 3, 1.
Yes.
But if I did the insert, I can use the index 0 to say like, hey, put it in index 0. But here it work. It's confusing a bit.
Yeah.
But let's see. Maybe it. I'm not sure. It makes sense here. But this one here doesn't matter because the elements are maybe because this one empty. This one have only one. So like and we use insert, and we said add it in E. What we're gonna add, the element that we remove back. Okay, we have here. Now we have, so this is the function backtrack. We're gonna call it backtrack. We're gonna give it nums, and we're gonna give it empty current combination. Then we're gonna return result, right? Because at the beginning we have empty combination, we have this our nums, and then it starts building up. So run. Okay,
That's very good. Submit it.
see. 14, no! Let's submit again. That's a lie. Okay, 50, 60, let's submit again. That is a lie. Who have a question, please? I'm gonna post code without writing it, Mitala.
First, just try this one.
Okay, let me try. Let's submit.
No, try the one I wrote.
Okay.
I wrote some. Just try it.
Okay, submit. Wait, what is this? What?
You spend an hour and they have a function for it.
Really? Yeah, I think
Yeah.
Sabah did tell me something about this. Yeah. Wow. Iter tools, permutation. Okay, so this is a library called iter tools, and it have function permutations, which should give you all the elements. Wow. And this is so
Yeah.
fast.
Yep.
Okay. Yeah. But at least we did practice backtracking, building some muscle memory. Hopefully hopefully you find this guys useful. So I do have a meeting like in now, but I'm not sure if it's gonna go. So I'm gonna continue. Let's continue next. Let's go. But if I had to go at some point, I will go, and then we continue it in the next session. Please, if you have any question, go ahead. Yeah, so this solution is all about backtracking, and it is like the most efficient way. So let's remove this. We're done with this. Now the two LeetCode, we have lowest common ancestor and we have merge interval. Now this merge interval we did it before, but we're gonna repeat it. It's fine. And the lowest common ancestor, we did it, but we did it for binary search tree. This time we're gonna do it for binary tree. And the difference is binary search tree, you have some rules on how it's built. For example, the left side is always less than the root. The right side is always greater than the root. For this one, you can notice numbers are all over the place, so there is no rules. So given a binary tree, find the lowest common ancestor LCA of two given nodes in tree. According to definition of LCA Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P, Q, and Q as descendant, where we allow a node to be descendant of itself. Okay, if you confuse it, okay, we're gonna explain it right now. Okay, let's move this right here. And let's see the second one. And the third and the last example. Okay, so first let's understand what is LCA. So for example, if I set the lowest common ancestor of 2 and 6, I'm gonna start from root. Okay, 3, it's common for them, so 3. So to get, for example, to 2 and 6, right? So I'm looking for to these two numbers. So 3 is common for them both. Okay, 5 is also common for them both, and 5 is also common for both. So all are this are ancestor of 2 and 6, right? But the lowest one is the closest one. So 5, right? Now we need to find out if they give us 5 and 1. 5 and 1. So 5 and 1. So basically this one is easy because there is the roots and they are directly under it. So 3, 3. So the output is 3. So 3 is the lowest common ancestor. Now the other one, the other example is this one. Let's see what they are doing here. So 3, 5, 1, 6, 2, 7, 4. We have 5, we have 4. 5 here, we have 4 here. Okay. Now to get to 5 and 4, we can, when we're gonna start from the root, 3, 5, 3, 5, 5. I will go to that in a minute. 3, 5, 4. So the most common ancestor is 5. Now this could be confusing, but because the node 5, it can be the lowest common ancestor of itself. So normally it's gonna be like 3. We can reach to 3 by 5, and 3, 5, 4, right? So the lowest common ancestor is 5, but in reality it is 4. So 4 is the lowest common ancestor of number 4 itself, and the second one is 5, and third one is 3. So 4, 5, 3. So this is the lowest common ancestor for number 4. Now if you apply that to the number 5, the lowest common ancestor for 5 is 5 itself, right? And then 3. And if you compare between them, which one they have in common, they have 5 and 3, 5 and 3. So we're gonna take the closest one, which is 3, right? Sorry, which is 5. Hope this one is clear. If not, please the link, please. Okay, so here's the link. Please let me know if this one is not clear, because it will help when trying to brainstorm solution. Any thoughts? I think recursion will work. Wait, give me a second, guys, please, or a minute. Okay, I'm back. So recursion is a good idea, and also we did it with the recursion. I'm sure there is many ways to do it with recursion. We can try to do something, you know, like let's take this picture and let's do something here. Let's say, let's create our P and Q. Let's do someone is hard, like for example 5 and 8. Now 5 and 8, it is 3. Which one could be the most hard one? Do we do like 7 and 8? Any suggestion? Please write in chat. Or like what will be like the case that we build our logic on? So we can, okay, let's use 8. Oops. Let's use 8 and maybe 6 or 7, but let's use one on the edge on the final, so of 7, and use one close here, or like 2 it's between middle, and use 8 in the final. So if there's any edge case or something, we're probably gonna cut it. So the most lowest ancestor is 3, right? Right, this is the only one that's even the chair. So 2,
Yes.
2, 8, and the LCA is 3. Okay, so let me put this here like this, 2, and this is the what we need to find. Now if we did recursion or like DFS, there is a thoughts we can think about. So we're gonna launch DFS on all of the tree, and like, so we're gonna launch at the root, and we're gonna check is your wait, we didn't check the last example. What did they say? 1 2 p1 2 1. What is 1 2? So 1 2, so 3, this is the root. The most common ancestor of 1 2,
and the left is 2.
So 1, because because this is the LCA of itself. Okay, I thought we missed something. So we launch a DFS on this one. This DFS can ask question. Question, or like, let's say is your left, and or like it's gonna so this gonna launch DFS on this, and we're gonna check if left and the right, it's called p equal to r, or like q equal 8. P equal 2. I don't think the order matter. So first it makes sense to check if this actually equal P or 2. Okay, let's not build it like this. Let's say we launch DFS on this one, then this gonna launch another DFS on the left and the right, right? The goal is we are looking for 2 and 8. So when we launch the DFS here, we can ask question, are you 2 or 8? It's gonna say no, I'm 5. Okay, can you launch more DFS on your neighbors? It's gonna, okay, no problem. So it launched on 6 and 2. Now 6 and 2, they ask the same question. Are you 2 or 8? It said yes, I am 2. Then this gonna return 2. And this 6 gonna be asked, are you 2 or 8? No, I am 6. Okay, can you launch DFS on your neighbors? It's gonna, I don't have any neighbors, so this like neighbors gonna return like nothing. And this 6, it's not 2 and 8, so it's gonna return nothing, or like 0 or -1, like something to differentiate that we didn't find any element here. So let's say maybe -1 or none, for example. Then this 5, it's have a value from 2, because we did ask 5, like, are you 2 or 8? It said no, I'm not 2 and 8, but let me check my neighbors. And then it's gonna say, okay, I did find 2 in my right path. Then we're gonna return this 2 here, right? 2. So the root understand that, okay, I have 2 somewhere in here. right? Now the def is also it launched on the right side, so this gonna be asked same question, are you 2 or 8? You're gonna be like no, but let me check my neighbors. So you're gonna launch another def is on this. This is gonna be like, are you 8 or 2? It's gonna say yes, I'm 8, so this is gonna return 8, right? And this not 0 not 8 is gonna say let me check my neighbors. There is not any neighbors, so they're gonna return none or -1 or whatever. This is gonna also return none, like I didn't find anything. And this one is gonna be like, okay, I did find 8 actually in my right path. Where is it? 8. And then this tree is gonna be like, because let's think about it, like if someone above it asks, are you tree? So someone asks the root, are you 2 or 8? And tree said, no, I am not. I'm tree, but let me change my neighbors. So it lands the both defs, and then tree said, oh, you know what? The left side did return 2, and the right side did return 8. So I guess I am lowest common ancestor of them, right? And then we're gonna return the root. So wherever we have a case where we get from the right or the left these two value, doesn't matter the order, we could be 8 from here and 2 from here. We can't ask the children of node 2, this one. So because when we were like in the 5 asked 2, it told her like, are you 2 or 8? It said yes, I am 2. So like there's no need to check here. We found what we want, right? So it's gonna return. So it's gonna return.
But 8 could be an children of 2.
Oh, okay. Let's bring this one. Let's see this one, right? 5 and 4. Like 5 and 4. So 5 and 4. So our P is 5 and Q is 4. But we look for 8, 2. Yeah, maybe I'm missing something. I can sense it. So when we find 2, do we like continue? I guess we're gonna. So this gonna
until there is no children. I think to make sure there is no children we're looking for.
So this, so when this 5 gonna launch in 2 gonna be like, are you like P and Q? And P and Q, it's gonna say yes. Okay, let's do an example like this one. Let's see if it's gonna, how it's gonna work. All the nodes. Oh yeah, I think you're right. I think we should check all the nodes. So for example, we have 5 and 4. So this one is tricky, right? Because they are not in different side, they are in the same path. So we're gonna launch Davis on this. This is gonna be like, are you like 5 and 4? It's gonna know, let me check my neighbors. So it's gonna launch another Davis here. And another Davis here. And this is gonna be like, are you 5 or 4? So this gonna return root, which should not make sense, right? Because we need to continue. Now how we can do that? Okay, let's say we did not do that. We did not return. We found like 5. We said, okay, it is 5. Do I save it somewhere? because at the end I need to find 5. Could you take a minute and think?
You launch DFS on the children. So you launch DFS on the route to left, and you launch DFS on route to right.
So I don't launch it on this.
If you have the like the route,
Okay.
if you find the route, return. But you keep launching after you keep launching for the left and for the right.
Okay, so from the start, I don't launch DFS on 3. So I'm gonna launch one on the left. One.
First, you check if are you looking for 3 or not. Is 3 a value you're looking for or not?
Okay, so I'm gonna check if this value right here, is it 5 or 4? If it is yes, one of them, I'm gonna return it because it is the lowest common ancestor of itself, right?
Yeah, it's the very first value you're looking for. The very first value in the tree.
Oh. Okay. And then I'm gonna launch left and right. So I'm gonna launch DFS on here and DFS on here. And then this gonna check if this value is 5 on 4. If it is 5, it's gonna so when I launch this DFS and they ask the question, is this 5 or 4? I'm wondering. If I return it, I'm gonna return it with itself. I'm gonna return 5.
Return to a variable. So you check if this variable has value. Like if this value if this variable actually has something in it, then you know it's a root. If only one variable has value to it, is not equal none, then you know it's the root is only one of them, either the left or the right.
So a variable, then I'm gonna put inside it what?
The DFS you're going to launch on the left. You launch it on a
you put it in variable. Okay, yeah, left. It's and then left, I'm gonna to right.
DFS root left.
Okay,
right.
Right.
DFS root right.
Okay, so I'm gonna put this in a variable. So this one is gonna return 5. It's gonna become 5, not 5, right? 2, 3. And this one, it's not gonna find it. Not gonna find 4 here, so it's gonna be end up like returning none.
It will return none. Then you know the first common ancestor is 5, the one you're looking for.
Okay. Then I will return 5, but I'm not sure if okay, maybe it is P and Q will exist into so they're gonna be always exist. So if I didn't find them here, okay, that is the key. So if I didn't find it here, it is here. So I need to find only one. If I find only one, then that's it. Wow. Okay, so P and Q will exist in the tree. What else? P and Q are different. All node val are unique. Okay, so that is the key. Oh my god, I was hurting my head. Okay, let's try to clear the fog. So basically we gonna have two variable, right? Left and the right, and we are in the root. So we are looking on 5 and 4, right? So if we launch defs from the root, we're gonna launch it on the left, on the right. Now if this if this return none or this return none, by the way, they will not be, it will never be like both of them none, because we're gonna find either 5 or 4 first. If we didn't find it, we're gonna find it somewhere, right? Either one of them gonna be none, which mean the other side have both of them. If they are like in this side or this side, we're gonna find. So the goal is like, hey, let me go through the left and the right, find at least one of them, because if I find at least one of them, if the other side is none, then I find the LCA. If the other side not none, I'm probably gonna 100% I'm gonna find the second one. Okay, let's clear it more by doing this simulation. So I have the root. I'm gonna launch defs on 5 and 1. Then this gonna be like we're gonna ask the same question. Are you one of this? Gonna say yeah, I am 5. So we're gonna return it. But why? We still have 4. We're still looking for. It just like doesn't matter. Why? Because if the both elements or node are in the same node, the first one gonna be always the first LCA. So if we put 5 and 4, or like 5 and 6, 5 and 2, or like 5, 7, the first one we're gonna find is gonna be always the LCA. So when we find it, we just give up. We find it. There's no need to continue. Please let me know if this point is not clear. Because as we said, like the 5 is ancestor of itself, right? For example, if we said what is the ancestor of 5, we're gonna be like, okay, 5, so this is ancestor of number 5. 5 is ancestor of itself. So any node, it's ancestor of itself, or like lowest ancestor of itself. 5. And what else? 3. So the lowest ancestor, common ancestor of this, or like ancestor of this, is 3. 3 and 5 itself. We're gonna go to 4. The lowest ancestor of 4 is 4, right? Itself. And 2 and 5 and 3. So the far one is 3. Now which are the common here? Notice they have 5 common, right? So basically when I'm going looking for 5 and 4, the first one I'm gonna meet, okay, let me just return. And when I'm gonna return here, I'm gonna take decision, because I'm gonna take a decision of what? Either I'm gonna return 5 as lowest ancestor, in case this return none. Because if this return none, it means the both nodes are on this side. But if this didn't return none, which means this is not in this side, which means this DFS did find 4 here somewhere. So if this return 4, I'm gonna return 3, because at that case it's gonna be like 3, somewhere here there is 4, somewhere here there is 5, so the lowest common ancestor is 3. As I'm going fast, is it clear? Who did not understand this? Maybe you can try. I'm lost. Okay, I did probably go so fast. Okay, let's go step by step. So what about this part right here? The 5 and 4. Did you understand that 5 is the common ancestor? Okay, so we know this is the common ancestor. Did you understand, like, did you get that if we are looking here and we find 5, we can just return, we don't need to keep going? Did you understand this part? Okay, so now we said that, so like, so where that's coming from is like the bigger number. So this 5 right here is gonna be how to say, this one is hard to explain. Let me try something. So this 5 is common ancestor between this and this, right? And between 7 also. So this 5 is ancestor of all of this, right? And if I'm looking lowest common ancestor of 5 and any number that is branch of 5, so either 6, 2, 4, 7, 7, the lowest common ancestor between them is gonna be always 5. It's gonna be, it's like a rule. So if I said, give me lowest ancestor of 6 and 5, what? It's gonna be 5. Lowest ancestor of 5 and 2, it's gonna be 5. Lowest ancestor between 5 and 7, again 5. Lowest ancestor between 5 and 4, again 5. So when I'm going this side and I find 5, I'm gonna just return. Why? Because if the second number is under it, then there's no need to search. If under it, it automatically is gonna be low, since they're the first one, which is 5 that I'm looking for. Okay, so now we understand this part. So if I find lowest ancestor, I just come back, I return it here. Here is it, 5. Now we don't know if 4 is here, right? That's why we launch another defis on the right side. Now the right side, what's it gonna do is like, it's gonna do the same thing. It's gonna go, are you 4? No. Are you 4? No. Are you 4? No. Are you 4? Are you 4? Are you 4? Sorry, it's asking both questions. Are you 4 or 5? Are you 4 or 5? Are you 4 or 5? Because they don't know that 5 is here. Both of them are saying no, 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 no. So this 3 got no from here. It's like saying, hey, I did search all the right side. There is no 5, no 4. What do we understand? And because we are we know that P and Q exist in 3. Isn't that kinda mean like the bots are in this side? Right? Is this clear? If we didn't find it here, it's meaning that they're both in this side. And if they are both in this side, and we find the first one, isn't that mean automatically that it is under it somewhere? And if it is under it somewhere, that means the first one that we found, it is LCA. Right? So we return, in that case, 5. Now, let's say we found it somewhere on the right side, right? We found it. So in this case, what we return the first LCA we found. Now, if we in the right side, we found one of them, right? So in this case here, we found 5. So automatically, if 4 exists in the right side, we're gonna find it. We go here, let's say this is 4. We go here. Are you 4 or 5? No, but let me check my neighbors. Are you 4 and 5? Yes, I am 4 and 5. Okay, return me to here. Are you 4 and 5? No, I'm not. Let me check my neighbors. There is nothing, none. This one gonna say, oh, I found 4. Okay, let me pass it to my boss. Okay, here is it. I found 4. Then this gonna have to take decision. We'll be like, oh wait, I have 5 from here and 4 from there. Then this gonna be like, okay, so I am the LCA, right? So when the node have the left variable have something and the right variable have something, it means the root is the LCA. When only one of them have something, if this is X and this is something like a number, then we know this is the LCA. I think with pseudocode and the code it will be more clear. So let's try to, okay, who have any question about this? If not, we can like try write pseudocode. So it is gonna be recursive way. So let's start from base. So our base did stop when we go to this here and we don't find any node. So if root is none, okay, so if root is none or not root, okay, if root is none, I mean there is no node here because we pass a root, so this gonna be the recursion. If we didn't find the root here, we're gonna return with empty, right? We can like anything we want that say, okay, there is nothing here, like return -1 or like just return none. Return, for example, none. And another thing, when we launched defs on the left or right, what was the question? Are you P or Q, right? So we need to ask that. If the root equal P or the root equal Q. So this was the question we were like asking. 1, are you 4 and 5? He said no, I'm not. But when he said yes, for example, when we were dealing with 5, when he asked 5, are you 5 or 4? It said yes. Then what we did, we returned 5 to the caller. That's called this function. Or if it was the first root, so it's gonna return that. So return root, right? So return root, and then we gonna declare 2 variable, left and right, because if this is not 5 and 4, the answer was like, okay, I'm not 5, I'm not 4, but let me check my children or like my neighbor, right? So it have left and right, left, right, and this gonna it's gonna like call the same function. So lowest, let's just call LCA, which is this function itself. We're gonna give it the left and the right this time. So LCA root right, and we're gonna pass P and Q. and this one we're gonna give it left. We're gonna pass left P and Q that's it looking for. So now that for example 1, it not P and Q, it did launch DFS on the left and the right, which is this one, right? It's on 10 and 8, and 8 also didn't find something. It's returned none here, none here, right? So if left and right is none. Okay, so maybe we start with this, or let's start with the case when 3 had 5 and 4 coming from left and side or right. So if the node have left and right value, have like a valid value, which means if you have a value coming from left and right, then the root is the LCA. But if you have value coming only from one side and the other side is none, it means that is the LCA, the other value, right? So this is the two cases that we found. So if left and the right, which means if left and right have valid value, then return the root. Return root. Okay. And the other case was when we found out 5, when we had like 5 and 4 here. We were like, we launched DFS on 3, and 3 did launch DFS on 4 and on 1 and 5. Right did return none because it didn't find any 4 here, but left actually found 5. So we're like here, if left it needs some way to say like if left is true, or like have if left and right is none.
You have a return case for if left and right. So right now you just if left, because if it met left and right, it will return root.
If left and right,
It will return root.
yeah, but this one is none, so this is gonna be false.
Yes, so it will go. It find left is true. It will return the left.
Oh, return left. Okay, so if they are not, if they are both not right, so only one of them.
Right. Yeah, only the right. Remain.
Okay, and then if right is, then return right, I guess. Or I guess we can do else here. Because if they are both have value in it, which means left and right did return something, then we're gonna return root. But if we have left, then we're gonna return left. If we didn't have left, that means we have right. What if we don't have any of them? Then we're gonna return nothing, I guess.
Actually, in construction, they will always exist.
They also exist, yes. So we're gonna find something. Okay, so this is our DFS. Let's write it to code. Let's see. Please, if you have any question, go ahead. Do not be shy. What I'm doing? Yeah. Okay, so if root is none, return none. If root equal P or root equal Q return root, and the left, wait, what I'm doing, left is, it's gonna be this one. Do I need to do self? I don't think so, right? So root P Q and something similar, right? And then F left and right, return right, oh sorry, return root, F left, return left, else return right. I think I need self here. I don't remember. It's not defined. Self. Okay. Nice. 39. 39? 93. Oh my god. Okay, that was good. Like, if you really understand this one, wow, that was amazing. Yeah, that was cool. So hopefully you guys understand it. We can keep going. We have the last one. But if you like, you wanna go, it's okay. You can like watch the recording after. So also, if you have question about this one, please go ahead. So let's go to merge interval, which is the last one, and we kinda did it, or we did it. Yeah, we sure did it. Let's see if we can do it again. So let's see example. Okay. Let me post the code. Yep. Okay, sorry. Let's read the problems and try to understand what they want from us. Let's make sure we read this constraint because it helps a lot. So the problems we have is, given an array of intervals start and merge all overlapping, and return an array of non-overlapping interval that cover all the interval in the input. So we have 1, 3, 2, 6, 18, 15, 18, and we need to return 1, 6, 18, 15, 18, since interval 1, 3 and 2, 6 overlap, merge into 1, 6, and 1, 4 and 4, 5 become 1, 5. So let's see. So we have 10, 18, so like 1, 2, or like, let's do this to make it clear. So we have 1, 3, then we have 2, 6, then we have 8, 10. Then we have 15, 18. Okay. Now, what do we do here? How we can visualize this? We want to see the interval, right? So if we put it, we can see that this 1 3 is intervaling with this, right? Because 2 is somewhere here, and 8 is not intervaling with this. 15 is not intervaling with this. Now we need to merge this interval because this overlap, right? This overlap here. So what we can do is think about this, like this color like this, and we're gonna push it down like this. So basically this 6 gonna go down with it, and because it is 1, there is no more of this 3 that was there, and we have 1 6, which is that's what we want, right? So 1 6 18 15 18. So we're just gonna combine them together whenever we find overlap. So first we need to detect overlap. So we need to loop to these numbers, and we need to detect overlap and then merge it. Okay, how we can do that? Any idea, any thoughts? Do you see the code, or like do we think about it a bit? What we need to do? Okay, see sort in here, lambda function. Okay, why we need to sort it?
We no, we need to sort it because it makes it easier.
Oh, because maybe it is this right here. So
yeah,
we need to sort them in order.
yeah. And we have the template for overlap. We already know the template for the overlap, and we have the template to merge overlap. We have these two templates before. We used it many times before.
Yeah.
So we just check if is overlap, and if there is an overlap, we merge.
Okay, so if we write pseudocode for it, first we're gonna sort interval, so to make it easy. Okay, they are now sorted, for example. Now we need to loop on each element. So we're gonna start from the first one. 1 3, right? 1 3. And we need to compare it with all.
Not with all, with the next one, because we already sorted. So we compare 1 3 with 1 6 or 2 6. I can read it. Then there is overlap. We merge the overlap.
Okay.
And we append it to the last element in the result or whatever we are going to.
Okay, so we're gonna get the first one.
Yeah, we put the first element. We take the first element, we put it into a result array, and compare the last element in the result array with the next element in the. So we start the comparison. We start the looping from the first element, not from 0, but from 1. Not from index 0, but from.
Because this is we sorted, so this is gonna be always the first element. So we're gonna add it to. Yeah. We're gonna add it to a result, but What if we had to change it because it's gonna become 6? If we push
Yeah,
1, 3.
yeah, that's where the overlap. We check for overlap. If there is an overlap, we merge. If there is no overlap, we add the next element.
Okay, what? So maybe we don't push it at the beginning until we merge.
We push it. We compare this one to the next one. How are
Okay.
you going to compare? How are you going to compare?
Oh, okay, I see. When it
You
is
don't get out index.
okay, so we're gonna compare it with this. If we merge them, we need to keep going because we don't know if there is more merge, right?
If there is merge, you change element this element. You make it. You change it.
Okay, I start remembering now. So first we're gonna get the first element. Let's say we're gonna put it in this. We're gonna put it here. Let's call it A, and then we're gonna loop on the rest of the array, starting from the next element, right? And then we're gonna compare 1, 3 with 2, 6. So get the first element, loop on rest of array. Rest of array, I mean it like we remove this one, we're gonna skip it because we want to compare this that we skip with the rest. So we're gonna loop on the rest of array, and basically we're gonna compare if there is a merge, if there's a overlap. Now, how to know there is overlap? We compare index, let's say index 0 of this. So this is like a rule or something that you can memorize if you want. So index 0 with index 1 and index 1 with index 0. Now you say if A so like if A is less than okay, let me do them different color. So we said A index 0 with index 1 and index 1 with index 0. If this less than this, let me write it. So let's call this B. The one that we loop in on is B. And this one that we take it at first is A. So if A0 is less or equal B1, and B0, which is rare, B0 is less or equal A1, then I know there's overlap. Let's see how it works. So if this number is less than this number or equal to it, okay, and same time this number is less than this or equal to it, then I know they are overlap. So how it works, let's say we have 1, 2, 3, 4, 5, 6, and we have the one is 1, 3, so we have 1, 3, and we have 2, 6, so and we have 2, 6. Now we can see here the overlap, and our condition was like if this is less than this and in same time this one, this B0 is less than A1. If this if these are less than each other, or like if b is less than b0 is less than a1, and these two are like this less than this, then there's like what is called overlap. Now is there is a case where this not gonna be less than each other? So for example, if we just move this far right here, we're like this gonna stay the same, right? But this one is here, the one above. So if we check the green one, which is this, is this less than this? No, they are not. So basically there's no overlap. There's no need to keep going. But when they are this less than this, and then we go to check the second part, which is this greater than this, or like is this less than this? Okay, so this is the formula how to get to overlap, to catch this overlap here. When there is here, we know that this 1, 3, and 2 6 overlapping. We need to mix them. Now we need to mix them. What that mean that 1, 3 need to become 1, 6. Right? So this 1, 3 gonna become 1, 6. And the formula to do that, we can do it like with the main. It's like we're gonna do a, the min and max. So we're gonna do min, because now we have this overlap, right? And we know this is 1, and we know this is 2, and we know this is 6, and we know this is 3. Now if I am gonna mix the overlap, and they're gonna become like this, 1, 6. If you think about it, it's like we take the minimum between of the both interval, we put it here, minimum, and we take the maximum between the far right of the interval, which is 6 and 3, and we put it here. So basically this a we're gonna change to the minimum between the, we said a0 and b0, a0 and b0, and the max of the same a1 and b1 and b1. Okay, now this is in case there is a conflict, or like this overlap. What if there is no overlap, like this? There is no overlap. I'm gonna just add it to result. That one that it was an A, I'm gonna just add it to result. Right? But this one,
if there is no overlap, you append.
yeah,
If there is an overlap, you merge
append.
the overlap and put it as the last element in the result.
Yeah, and someone might ask, like, okay, we didn't merge them. Okay, they are 1, 6. Why you didn't push them to a result? We don't push them because we don't know if we're gonna still merge them with the next one. Because when we're gonna loop, we're gonna compare 1, 6 with 18. And if there is no, like, if there is no conflict, that means it's gonna go else, which is gonna append them. It's gonna append A. So here we're gonna do like, if there is no merge, there is no overlap, else. append A to results, or like append A to results, and if I append A to results, that means I'm gonna loop and I'm gonna compare this with something, right? So we need I need the next element. So I'm comparing, let's say there is no so we're comparing 1 and 6, right? We did this, we did merge it, then we loop again, which means we were here, right? We were in 2 6, but now we combine 2 and 6 here, and then we loop to 10 8, and we compare it. Is 1 6 have overlap? It said no, so it didn't go. And this if it go to else, it's appended to result. Now results, we have 1 6. So we forget about 1 6 now. Now A should have this value, and this value we're gonna start compared with next ones. So A is gonna become equal B, because this is B, right? The one that we loop in here. So for B in intervals, but we need to skip the first one, or like just write it. 1, something like this. However, we can just say for B in intervals, skip first one, because the first one we get the first element, we put it in A. Let's call it right here A. We put the first element on it, so we keep looping in the next ones. Okay, so we merge 1 6, we compare, we move to the next loop when B become 15 18 and A become 10 and 8, and it's not overlapping, then it's gonna be else, then we're gonna be results append A in this case is 8, it's gonna be like here 8 10, A gonna be B, and B right here, and it's gonna loop, but it's not gonna loop because loop is end, so we need to add it at the end. Result append A, right? Because that last one gonna be always at the end. For B, okay, I will try to explain more, but before that, is who like trying to understand, it's still confused, or like who did get it? If you get this, guys, like I can just skip to code. Which part is confusing? Okay, so why we append at the end? We do it in else. Okay, so here, yeah, we append here, but when we finish the loop, we always gonna have this empty. The last element we always gonna be like outside of range or something. Like let's do a simulation. So we have let's start from the beginning so I can write something clean. Okay, so we said 1 3. Okay, so I think this is good. I'm gonna start with this. So we said we have 1 3, right? Now we know there's overlap, so I can move this right here. I can move right this here. Okay. So we said sort interval. Okay, here is it, they are sorted. 1 second. Okay, so here is it, they are sorted. Let's make a group room so it's gonna be easy. Okay. So we put a, what we're gonna put is in it, get the first element. Okay, here is it. Put it here. Okay, nice. For B in interval, skip first. So B is here. B. Okay, B is here. We skip the first one, right? Because so it technically is still here. It's still here, but we did skip it because we copy it in here so we can compare it. So we start from B. So just forget about this. If A, so basically this gonna check the if there's overlap with this here, with this A. That's all it's gonna do. Now this gonna detect overlap, so it's gonna mix it. So when it's gonna mix it, what it's gonna do is gonna change this A directly. So this A gonna go from 1.3 to 1.6. A gonna become 1.6. We fix overlap. Now this is done. It's here now in A. Now we're not gonna enter else. We're gonna loop. Gonna loop again, which means B gonna move. What happened now? We're gonna compare again A, the new A that we merged before, with this B. Now we're gonna say, okay, there is no overlap, so else. What I'm gonna do else? I'm gonna append A. So this A is gonna go to a new array, which is results. Is gonna go 1.6. Now notice that we merge it and fix it in the last loop, but to the next loop, then we are like, okay, we are safe. We can add this to result because we are sure that the next overlap or like interval have nothing to do with this, right? So we can continue now from here. Now that we're done from A, so this is done. Now A is empty. So if I loop again, I'm gonna compare 1518 with empty A, but I wanna compare it with this. So what we do is when we append it, we go to A and we append B to A. So A become 810 because I need this next loop. So 10, 810. Now I'm gonna loop. I'm gonna say 15 and 8 and 10, 8. Does it have any overlap? No, it does not. So else results append. What I'm gonna append 15, 18? No, I'm gonna need to append this because now I'm finally sure that it's not having any problem. So I'm gonna add it here, 18. Now notice we have a for loop which loop on all elements in the array. So when this reach the last element, there is nothing, it's gonna stop. It did stop here, so the loop stopped, but I didn't add this to result. Do you see it? Do you see that this loop stopped and we didn't add this? So we're like, okay, if the loop stopped, we're gonna always have the last element not added to the result. So we're gonna add it when the loop end. So now that loop end, we can add the last element, 18, and then return results that have all the elements we have. No, thank you for asking question. I'm always happy to explain. So let's see if this array is the same or we are just dreaming here. So 16, 18, 18, 15, 18. So it is the same. So I guess we can take this code and let's convert it to Python. And let's see. So we did it before, but it's always nice to like repeat LeetCode, because the more you do it, the more it's become familiar and it's become a way of thinking. So it's a sort interval. So intervals. Sort. Okay, interval sorts is basically by default it's gonna sort by the first number of the so like now we don't have number like 1, 2, 3, 4 that we're gonna sort. We have a array that have numbers inside, right? So sort by default is gonna take the first element of the array that's inside and sort with it. So you don't need to do any lambda or something. Now the results. So we said, where is the results? We didn't declare the results. So let's do our A. We get the first element. So intervals is the array and first element is index 0. And we need the results, right? Let's call it results. It's gonna be empty array. Results. Yes. And then we're gonna do for loop, b and interval, skip the first one. So intervals, we can skip the first one by like slicing. If we did one like this, it's gonna like cut the array. So if I have array 1, 2, 3, if I did this to it, it's gonna become 2, 3. Gonna become array of 2, 3. Which what we want, because we already put a here. And then F, so this is the overlap. Detect overlap. And this is the merge. Else result append a append result. Let's see. I'm sure this is the same code that we wrote before. So I forget array, so it's gonna be inside array. Okay, submit. Submit again. What happened? Why it's slow? I'm sure it was faster than this. Okay, here's. I guess it's just LeetCode. Oh, that's all, guys. That was the 3 LeetCode. Thank you for joining, and hope you guys enjoy this. That's all. If you have any question, please go ahead. If not, let's go have some good sleep. So next session gonna be it's gonna be Saturday. Now this month is gonna be hard a bit, because a lot of people have projects, especially the like core 13. We have like the last project month, so I thought to like stop this session until after, but that will be easy, right? So we have to do a hard 10. So I was like, you know what, let me challenge myself to keep doing this session even we have project, and see what's gonna happen. And like if people miss it, they can just check the recording, right? So that's it. Have a good night. Minatullah, Ricky, Layla, anyone watching from YouTube, have a good night. Bye bye.